and absolute values. Real numbers and absolute values. Can you see it in the back there?
Yes.
All right. Okay, I don't want to zoom it in too much. Then, when I'm writing, you can see it, and I don't feel it. In that case, you do let me know. All right. Yeah. And everybody, we will work with real numbers in this course. Oh. Okay. Occasionally, we will mention complex numbers, but that's just for informational purpose. Okay. Calculus, we talk about. We'll work on real numbers. Real numbers have two kinds. One kind is called rational number, and irrationals. What is a rational number? Rational number is any number which you can write it as a fraction of integers, p over q. It's a custom we always assume q is positive. P can be positive or negative. Something like 1/3 or negative 5/3. Right? Positive, negative, of course. Positive irrational numbers, negative irrational numbers. I think I left out one important one, which is 0, which is not positive, not negative. Right? Then we also, of course, for each part, we can divide it into real fraction or what? Or integer, positive integer. So I'm not going to write it down. Basically, this is the number system we work with. All right? Rational numbers. Then we have real numbers, irrational numbers. What is a irrational number? Anything is not rational. Yeah, that's true. If a number is not a rational number, that's an irrational number. Something like square root of 2 pi negative square root of 3. All right? A characterization for irrational numbers is any number which has infinitely many digits after the decimal point, and those digits are not repeated. There should be no pattern. Okay? Something like 0.135, 135, 135, 135, that's not irrational. That can be written as a fraction. All right? So irrational. Now, of course, we have operations on these numbers. That's what we know about plus, minus, divide, even we can take square root and those things. All right? Of course, there are order of operation. That's very important. Many mistakes appear because you don't obey the order of operation. Left to right, what first? Multiplication, division first. In every step, you are doing left to right. If there are parentheses first, inside the parentheses, still obey the same rule. Left to right, multiplication, division first. Right? Of course, that means square root, exponential function should be doing first because that's multiplication. Okay, obey these rules. I'm not going to say too much about it. That's the second topic in here. I want to talk a little bit about real number line. The real number line. It's a line with one direction specified usually to the right, and a point you call represent 0. That's called the origin. I have trouble with the R. All right? And then you need to specify the unit. What do you mean by the unit length? Then you know this is 1, this would be 2, this would be 3. Somewhere here is the square root of 2, because that would be 1.414. I cannot exactly pinpoint that point, but I know it's somewhere there. And this way, every real number, of course, go left. That's -1, -2, and -3, and negative square root of 5 is approximately -2.236. All right? So this way I can represent every real number A corresponding to a point on the real number line. Every point corresponding to a real number. So in a way, you can see the dots on this real number line is a picture of the number. All right? It's a picture of it. I think everybody is clear. This also gives us the order of real numbers. If the number is to the left of another number, the dot, that's smaller. Right? That's the order. And also tell us the absolute value. How do we define absolute value, everybody?
Distance from the origin.
Distance to the origin, right? So real number is the absolute value is always unless the number is 0, correct? Because the distance is always positive. And actually there is a formula which would be A if A is positive, or 0. If A is 0, the absolute value will be 0, right? The distance will be 0 to the origin. If A is positive, that's just the distance. A is just that distance, right? That's how we represent a point. But if it's negative, the distance is this distance, but the distance cannot be negative, then what should I say? It would be negative A. Actually, this is a sticky point for many students. They would say, oh, you said absolute value should be always positive, right? Unless the number is 0, but this is negative. That's just negative on the surface. A is negative. So negative A is actually what? Positive, correct? Now, how do we use this formula? For example, what's negative 2 absolute value? That would be negative 2 is actually 2. Some of you, I ask you this, you definitely would answer 2, right? But when I write down this, you might think, wait a minute, why do we need to do that? The problem is we often use mathematics, since algebra you deal with variables. Many times I really don't know that number is with the variable, is positive or negative. So I cannot write it down in a form which like negative 2. Easy, that's 2, right? Absolute value. But many times we need to use the symbols, depending on the symbol. Where is that variable? The quantity might be positive, might be negative. So this formula is one of the most important formula. When I was working along there, everybody, how many of you give me the answer negative 3? Yes, I have a few, I saw that, right? How many of you give me the answer is 1? More than that, I saw more than that. That's wrong. This square root of x a squared can only be positive. That notation, square root a squared, it's going to be a positive number. Any real number has 2 square root. One positive, one negative. But if you give me positive negative a, that would be wrong too. The answer this one going to represent the positive square root. So square root of negative 3, this is wrong, got to be absolute value of 3 because got to be positive negative 3, that's 3. When you write down this square root sign, it represents the positive square root. That's it. It cannot be a negative number. Alright? So remember that. This one, it got to be absolute value of a over a. So the formula I expect you to know would be a squared equal to absolute value of a. If you go one step further, that would give you this. Correct? So what is this? That would be 1 if a is positive, undefined if a is 0, because in no case you can divide 0, but divide by 0. You cannot divide anything by 0, period. Doesn't matter what is your numerator. Can we remember that? Sometimes we just forgot it. If I ask you this question, you think, oh, I know it's undefined. But when you do the problem, there is no answer. You just write down something. Oh, thinks 1 is reasonable. No, you cannot divide anything by 0, period. So undefined, it would be -1 if a less than 0, because absolute value of a would be -a over 1. A, right? So give you -1. That's the answer for the first quiz. No, for the first problem. All right. There are some properties about absolute value. I want to mention a few here, and this is especially important later on. Maybe not for this course. For 163, I hope you pay attention to this very carefully. A always less than absolute value of A or equal to. Clearly, if A positive is equal, if A is 0, it's equal. If A is negative, it will be straight length, right? And A plus B less than A plus B, the absolute values. This is called triangle inequality. And also A multiplied B equal to A multiplied B absolute value. Then you just multiply together. Take the absolute value of each one. But for this one, it's not true. All right? You need to be careful with this. And the rest I'm not going to mention it. The second part of my review, I think I can just finish it. Some basic algebra formulas. These are important. There are some formulas that are very simple, but if you remember it, it will do you a lot of good. If every time you have to start from the beginning, it takes you a long time. Okay? So here is some basic formula. I think everybody, you can help me out. A minus B, A plus B multiply A minus B. What is that? Thank you. A squared minus B squared. And also A plus B quantity squared. What about minus? Good. What about A plus B cubed? A cubed plus 3A squared B plus 3AB squared plus B cubed. This formula, you can use it both ways. When you do multiplication, that's you use it this way, right? When you factorization, you use it backward. And also, what about A cubed minus B cubed? This way I write it in the factored form. Okay. It would be what? A minus B, A squared plus AB plus B squared. A cubed plus B cubed, that would be A plus B, A squared minus AB plus B squared.
Can you move that up a little bit?
Yes,
Thank you.
that's what I mean. You need to let me know. Yeah, I see it perfectly on here. All right? So this formula, you might not be that familiar with, but we will need it. So I hope you get familiar with it. The proof is nothing but you just multiply it out. You can verify. All right? I think the review for this, I will go. There are other formulas I will give it to you, as we go down. All right? The third topic will be functions, which I will continue next time. Some basic concept about functions. If you want to try some problem, what about you try page 16, 43, 45, page 59, 3, 5, 11, 13, 14, 17, 19, and 23 to 29 are. I didn't finish my review, but you really don't need it. If you want to flip the page, try some problem, this is what I would suggest. All right?
Is that page 49?
That's page 59.
Okay, I thought it was 89.
Now, everybody, hope your first class didn't go so bad.